going to look at the imaginary number I raised to different exponents. The square root of -1 equals the imaginary number I. That means I raised to the first power just still equals the value I. Let's see what happens if we square I. That means I'm going to take -1 and I'm going to square it. And keep in mind that a square root and raising something to a power of 2 are inverse operations. Those undo each other. That means that I squared actually equals the value -1. Let's continue on and see what happens if we cube I. Now I'm going to use my rules for exponents. I to the third power is the same thing as if I take I to the second power times I to the first power, because I would want to add those exponents, and 2 plus 1 equals 3. Now I can replace each one of those. Since I squared equals -1, I can replace it with that, and I to the first power just equals I. So my simplified version would be that I to the third power equals -I. Okay, let's raise our imaginary number to the fourth power. That could be the same thing as taking I squared times I squared, because 2 plus 2 equals 4. Since I squared equals -1, I'm going to replace each of those with -1 and multiply, and I get a value of +1. Next, let's look at I to the fifth power. I to the fifth power, we could factor that as being I to the third times I squared. I to the third power, we have shown that we found that I to the third just equals -I. I squared equals -1. If I multiply -I times -1, I'm going to get a positive, and I get a letter I. And just a side note with I to the fifth, we could also make that I to the fourth times I to the first. Regardless, if I substitute in I to the fourth, which is 1, times I still get 1I. That's the beauty of math. As long as we do things correctly, there's more than one way to view things. Now if I continue on with I to the sixth power, the next value that I get would be -1. If I were to do the same thing with I to the seventh power, I would get -I. Then if I do I to the eighth power, I'm going to get a +1. This pattern keeps repeating, no matter how great my exponent is. So essentially, the only four things that we need are just to know I to the first, I to the second, I to the third, and I to the fourth power. So here's how we're going to apply that to try to find these three examples. I to the 12th power. Well, here's I to the first, second, third, fourth. We mentioned that the pattern continues. This would be I to the fifth, I to the sixth, I to the seventh, I to the eighth. Next it would be I to the ninth, I to the 10th, to the 11th power, and then to the 12th power. I to the 12th would be the same thing as the value 1. However, we won't want to try to count those each time because we're going to look at exponents that are larger than some of these. So mathematically what we would do is we would look at our exponent, which is 12, and we would want to divide that by 4. 4 goes into 12 3 times. That means there would be no remainder. So if it's divisible by 4, our value of I raised to that power would just equal the number 1. Now when I look at the second example, my exponent's 15. I'm still going to divide that by 4. It doesn't go in evenly. However, I'm going to take a look at my remainder. This means that 4 would go into 15 3 whole times. There's 3 left over as my remainder, so I would go back 1, 2, 3. That means my remainder is the same thing as being I to the third power. So I to the 15th should equal negative I. My last example here would be 18. Four doesn't divide into 18 evenly, however I would have a remainder of 2. That means I to the 18th power should be the same thing as I squared. There's a correlation between the remainder and the exponent. Since I squared equals negative 1, I to the 18th would also equal negative 1. We're going to look at 4 more examples. I to the 42nd power. Now it's not practical to go through and just keep counting up. So what I want to do is divide each of these by 4. 42 divided by 4 isn't a whole number. I know that 4 will go into 42 10 times. My remainder would be 2. This remainder corresponds with that exponent. So I to the 42nd power should be the same thing as what I squared is, so this one equals negative 1. My next one, 56. If I take 56 and divide it by 4, I get a whole number. It is divisible by 4. So I to the 56 is the same as I to the 4th power. 238 is not divisible by 4. However, if I were to divide that, I would have 59 and there would be a remainder of 2. That means I to the 238th power should be the same thing as I squared. And then my last one, 123. 4 will go into 123 30 whole times. There will be a remainder, and it would have a remainder of 3. That means in this example, I would want to use the answer for what I cubed equals. I cubed equals negative I. Here's 4 to try out. So you can press pause. Once you're done, you can hit play again to see the solutions. But you want to take each of the exponents, divide it by 4. If there's a remainder left, that remainder corresponds with which of the 4 values you would want to use. And here's my solution for these 4. And to the left of each one, I did show what the division is. In my second example, 52 is divisible by 4. So that one's the same thing as what I to the 4th would equal. And then I showed what my remainders are in the other 3 examples.